Good evening. I'm going to go over my Module 4, Chapter 6, Zoom Report. Okay. Okay, my first page didn't scan in too well, but this is um, pattern blocks are popular and manipulative that is used successfully in many elementary school classrooms. The four shapes below are included in any set. So we're going to start out as how many rhombi will it take to make one hexagon? If you could see my drawing better, you could see that 3 rhombi equals 1 hexagon. You had to do, there was one here, a half of one here, and a half of one here. So 1 plus 1, a half, plus a half, plus a half equals 3. The next one you can't really see down here, but it is how many trapezoids does it take to make one hexagon? It takes 2. I have one here and one here. So it takes 2 trapezoids to make one hexagon. Okay, these you can see a little better. How many triangles will it take to fill one hexagon? So here's all my triangles, and there's the hexagon. It takes 6 triangles to fill one hexagon. And now we're changing to the trapezoids for the base now. How many hexagons does it take to fill a trapezoid? Okay, here's the trapezoid and here's my hexagon. It only takes a half of a hexagon to fill a trapezoid. How many triangles does it take to fill a trapezoid? Here's 1, 2, 3. It takes 3 triangles to fill a trapezoid. How many rhombi does it take to fill a trapezoid? Here's the trapezoid, here's the rhombi. So it takes 1.5 rhombi to fill a trapezoid. Triangle for the base now. How many triangles will it take to fill a hexagon? Here we go. We got 1, 2, 3, 4, 5, 6. It takes 6 hexagons, or 1 hexagon to fill 6 triangles. And our fraction would be 1/6. How many triangles for 1 trapezoid? Here's 1, 2, 3. So our fraction would be 1/3. How many rhombus equal how many triangles? So for every 1 rhombus, it takes 2 triangles to fill it. Now we're doing the rhombi as the base, and it takes 2 triangles for every 1 rhombi. 1 trapezoid equals 1.5 rhombi, so the fraction would be 1 1/2. 1 hexagon equals 3 rhombi, so the equation would be 1 1/3. Our goal is to write 4 sets of fractions with 3 fractions in each set. We started with the hexagon and seen how many of the trapezoid, triangles, and rhombi would fit into the hexagon. I did the questions so that you could understand them. For an example, how many triangles would it take to fill 1 hexagon? Well, it takes 6 triangles to fill a hexagon, so the fraction would be 6 triangles over 1 hexagon, which simplified is just 6. You do this for all sets of shapes. Now on to question 2. A man bought a length of rope at a hardwood store. He used a third of the rope to make a boat hanger for his canoe, then used a fourth of the remaining piece to tie up a roll of carpet. He now has 36 feet of rope left. What is the length of the rope he originally had? Okay, here I drew a rope, and first I used the length that he had left, and I equaled it into 12 feet apiece. So I started with what was left over, the amount of rope there was. I drew the rope marked off for the amount that was left, the amount for the painter, and the amount for the carpet. The length on the left over of the rope had to be exact same length. It has to be the same length as the rope used to tie the carpet. So 3 parts equal 36 feet. So that is 12 feet times 3 equals 36. Now split the rest of the rope into 12 feet pieces. Therefore, the original amount of the rope purchased is 72 feet long. Okay, on to question 3. Represent each of the following fraction function facts with a fraction strips model and a number line diagram. And I have those right here. We're going to start with A. We have 1/3 plus 1/2 equals 5/6. Here's the fraction strip of 1/3, 1/2 plus, and this is your equal sign, and then we have 1, 2, 3, 4, 5, and then 6. So 1/3 plus 1/2 equals 5/6. And you can see the same thing down here in the number line, 1/3 and 1/2. 1/3 plus 1/2 equals 2/6 plus 3/6 equals 5/6. Now on to B. 1/2 plus 3/4 equals 5/4, which simplified is 1 and 1/4. Here's my fraction strip for that, and my number line. 1/2 plus 3/4 equals 2/4, plus 3/4 equals 5/4 equals 1 and 1/4 simplified. C, 3/4 minus 1/3 equals 5/12. Here's my fraction strips. And now that you're minusing, you have to make a fraction. So I did that right over here. Here's my 3/4 equals 9/12, and I made a fraction for 2, and my 1/3 equals 4/12. Okay, and D, 3/4 minus 3/6 equals 1/4. Here's this part, and I did the same thing over here. I had to make fractions, so 3/4 equals 9/12, and 3/6 equals 6/12. Question 3 has A and D. The goal is to represent the fraction equation with the fraction strip and number line. I showed each fraction in a fraction strip and a number line. Sometimes the number lines can be confusing, so for me, I had to refer back to the book and do some research to remember how to do those. If you ever get stuck, don't hesitate to ask. So now we're on question 4. Represent each of the following fractions, function, fact, with the fraction circle diagram. So here's A, 3 times 1/5. How many fraction circles did we need? We needed 1, 2, 3. So each of these have 5, and that's our 3. And then each of them have 1 out of the 5. So come down here, and our answer is, here's the 5, and that equals 3/5. So here's the answer, 1, 2, 3, and this whole is 5. So B is 3 times 2/4. How many fraction circles did we need for this one? We needed 3 also. So here's 3, and then 6/4, which simplified is 1 1/2. So here's 1, and then here's the half. 5 times 5, 8. So we need 5 fraction circles, 1, 2, 3, 4, and 5. And that is 5/8. And it equals 3 1/8. So here's 1, 2, 3, and 1 out of 8. D with the negative, it's the same as up here, but I wasn't for sure exactly how to do that one. So on 4, goal was to show the fraction with the circle fraction. Go to step by step on how many circles you needed to show the fraction. Draw it out and explain what you did to get the answer. Okay, question 5. Let's see, a unit square is proportioned into 7 pieces, A, B, C, D, E, F, and G. What fraction gives the area of each piece? This one, you just had to figure out, because if you put an X all the way through it, that would be 4 triangles. So the area of A would be 1/3 or 1/4. The area of B would be 1/4. The area of C would be 1/16. The area of D would be 1/8. The area of E would be 1/16. The area of F would be 1/8. And the area of 6 would equal 1/8. In number 5, it gives you the square that is cut into different pieces. It is triangles and rhombus of different sizes. There are A through G inside the square, and you have to determine the fraction of each area of piece taken up. And number 6, list all the ingredients for chocolate brownie given at the right to make 16 brownies. Use the list to decide how much ingredients is needed to make 12 brownies. So here's our list of ingredients. We had to find what fraction to divide 16 by to get 12. The multiple of all ingredients, then multiply all ingredients by that fraction. So here we go. 12 divided by 16 is 0.75, which in a fraction equals 3/4. So you need 3/4 of the recipe. And right here, we had to times all of them by 3/4. So 1/2 times 3/4 equals 1/4 cup of butter. 3 times 3/4 equals 9/4, which simplified is 2 1/4 ounces of unsweetened chocolate. 3/4 times 3/4 equals 9/16 cups of sugar. 1 1/2 times 3/4 equals 3/8 of a teaspoon of vanilla. 2 times 3/4 equals 3/2 equals 1/2. 1 1/2 eggs. 2/3 times 3/4 equals a cup of flour. In this question, we were given ingredients to make 16 brownies, but only needed to make 12. You had to determine what fraction to divide everything by to only make 12 brownies. The fraction is 3/4. So then we multiplied each ingredient by 3/4 to get how much of each ingredient needed to make 12 brownies. I hope you enjoyed my presentation and thank you very much.